Hi, my name is Tanner Stoker, and this is my final for Physics 3030 of the Universe, Where Do Black Holes Come From, and the Process and Creation of a Black Hole. And I chose this topic because not only is it interesting, but it shows me that anytime we're really studying and analyzing certain things in the universe, not only do we gain a better understanding of those items, but we can also have further knowledge open to us as we research them. We've seen that occur a lot over the last century plus, where scientists have studied certain things in the universe and they've been able to open up new avenues of potential research to do, which can really open our understanding of the universe. So first and foremost, how is a black hole created? The life of a star. So black holes, you can see here in this picture below, this lower image is going to kind of show the life or process and creation of a black hole. We start as a stellar nebula, which eventually moves into a massive star, then a red supergiant, and then a supernova. And those explode and they can turn into neutron stars or black holes. We're going to discuss that here next. So a supernova explosion, we have a situation where we have the battle between gravity pulling in and pressure pushing out. The nuclear reactions produced in the star produce the right amount of pressure and energy to push outward, whereas gravity pulls inward. And this ultimately, for the most of the life of a star, balances out perfectly. But when a star runs out of nuclear fuel, gravity takes the upper hand, and this compresses the core even more. So you know that gravity is pulling in, the nuclear reactions run out, so gravity starts to really compress the core. The more massive the core, the greater the force from gravity is, eventually collapsing it. Okay, and that's where we get the black hole. And this situation here where the gravity is really collapsing the core produces an event where the core compacts into a point with zero volume and infinite density. And we refer to this as singularity. So black holes, one of the most interesting facts about them is they're invisible, but yet also visible to a degree. Black holes have such a strong gravitational pull that not even a light can escape them once you pass that event horizon. So we can't see them themselves, we can see the effects they have on things around them. You can see here this black hole sitting here in the center is pulling matter from this large star over here. So we can't see the black hole, but we can see the effect it has on the objects around them. And this is kind of like, for example, an analogy, wind. We can't, with our naked eye at least, see wind itself, but we can see the effect that wind is having on objects around it, how it blows the leaves, how it moves the dust, whatever it may be. So by being able to see the effect it has, we know that the wind is there. And not only that, obviously it's a little different, we can feel it, but using it just in the ability to be able to see, we can see the effects wind have on the objects around them. So in conclusion, there's still a lot to learn about black holes. In fact, Stephen Hawking, one of the more famous scientists, has kind of put forward the idea that black holes, as we understand them, don't actually exist, and that event horizons don't actually suck things into the point where we no longer can research that information, that eventually they'll reemerge as radiation that we can understand. So that's really a lot of key research still to be done. And not only that, one of the most interesting things in conclusion here is we do have a black hole sitting at the center of the Milky Way galaxy. And that really shows the effect it has and the effect black holes have and why they're so important to study.